If you have a music keyboard, it probably has a set of these. I will call them expression wheels. And today we're going to see how to build a Eurorack module with a set of them. I got this set from eBay. There's always at least a few auctions of used wheels pulled from old gear. I think the best way to explain what this module will do is to first look at the faceplate. Expression wheels will mount here, and the position of the wheel will produce a CV output here. There'll be a potentiometer here and here to control the level of the CV signal and give it an offset relative to 0 volts. And note, before we go any further, as you can see when I turn on my guide layer, I put these potentiometers too close together. I wanted to make this module as compact as possible, and ended up needing to file down the sides of the potentiometers a little to get everything to fit. Don't be like me, use an extra 2 HP. For the VCA part of the circuit, the input is here, the output is here. Wheels control the level of amplification. Now let's look at the schematic. Because this module is made of two identical halves, I'm only going to cover half of this schematic. The circuit really begins with the potentiometer for the expression wheel itself, which is here. The voltage output is limited to around plus minus 5 volts by these resistors here. This trimmer and 100K resistor provides a zero adjust in case the wheels don't naturally center at ground. The trimmer here sets the gain of the op-amp, so a maximum span of the output can be set, and a wide enough voltage range can be achieved so that the VCA, that we will talk about in a minute, works properly. This potentiometer is mounted to the faceplate and controls the offset CV output, and this potentiometer controls the final output level. These two signals are mixed together so this non-inverting adder circuit, then through the output jack here. This trace here takes the unmodified CV signal and passes it to the VCA part of the circuit that we have right here. This Zener diode and these resistors limit the CV input into the LM13700 to a range that is useful. When the wheels are rotated all the way down, the VCA turns off, and rotated all the way up, the signal clips, and in the middle, the signal passes through the VCA at about the same level it entered. The signal itself comes in through this jack here, goes through the VCA, then through a unity gain follower, and out this jack here. That sums up the circuit design. Now to build it. Once all the parts mounted to the faceplate have been removed and replaced with solder points, this is what the schematic looks like, which is then laid out onto a PCB, which looks like this, with the silkscreen layers turned off for etching like this. Now let's etch it. And the faceplate. Trimming the PCB to size. And with the tarnish removed, the PCB goes into the ferric chloride. And there we have it, a perfectly etched PCB. Now to drill all the holes. Mounting all the parts to the faceplate. Now it's soldering time. think the PCB should go about here. Some hot glue to hold it in place. Now to make all the connections from the faceplate to the PCB. And there we have it. Time for a quick test before the chips are put in. And with that passed, the chips. After a little off-camera adjustment of the trimmer pots to set the gain right and zero both wheels, it is mounted in the rack, and we can see what it does. The CV output should be fairly obvious. Push the wheel up, the output voltage goes up. Push the wheel down, the CV output goes down. With the potentiometers on the faceplate controlling the span and a DC offset of the CV voltage. The VCA path works in a similar way. With the wheel in the center position, the signal comes out, more or less the same as it went in. Push the wheel up, more gain, even to the point of clipping. Push the wheel down, and the signal can be diminished to zero. Well, there you have it, expression wheels, mounted in a Eurorack module. Hope you enjoyed. Thanks for watching, and I'll see you next time.